Monday, May 3rd. Last week, new things were delivered to the south end of the solarium. These spools of orange wire were as tall as I am. Later, a truck arrived with another spool of black wire, not as big, but heavy enough to need a Skytrack to move it. Toward the end of the day, another truck arrived, and it had three, I think they're commercial water heaters. Not really sure about this one. When I was sure they were finished with wallboard, another huge truck arrived, and they spent a good part of the day offloading more into the third floor. An unusual rumbling made me go out on the balcony and look down. The temporary concrete mixing crew was now on the south side. Guy in the truck is loading sand into the hopper. Then he starts cutting open the bags of cement and adding them to the hopper also. After 3 or 4 are added, the hopper dumps into the bin that the guy is banging on right now, and it will make concrete. Another day was rainy. When I looked up toward the mountains, I wasn't sure if it was rain or snow, but it was pretty bleak that day. Rain pattered on the orange metal protective wall. As that day dried out, Big Cat continued to bring loads of dirt to backfill the retaining wall. At the end of that day, the guy with the compactor was working at the top level of the bricks. Soon they'll add more levels. When I walked around on the south side, I was thrilled to see that the end is pink now. On the street side, they have started painting the undercolor pink. Pretty soon they'll be loading these buckets of stucco up on the scaffolding. I hope they don't wobble, 'cause that would make a really big mess. One day there was a new sound out at the end of my balcony. These two guys were wrangling and clamping a framework that would eventually hold the windows for the solarium. Maybe the new sound was a little cussing. Few hours later, both the second and third floor had the frames installed. It was looking like more rain, so the guys had to unload the windows. Because of the swamp, they did it by hand. The truck couldn't get closer than door 3 for this job. Extra water was pumped down the street toward the low spot near the entrance. Trees and grass will be happy. Near the AL atrium, a crew is laying footings and getting ready to do rebar and concrete. Later in the day, I saw that black plastic was down. I think they poured concrete when I was on the north side of campus. After the rain, at the end of Gate 8 was a pretty good-sized swamp. There was a note posted on the wood stake. I think it said, "Beware of alligators." Coronado Wrecking and Salvage has brought their big bins, and they're starting to fill up quickly with metal. I haven't seen the insulation pile out here yet. Standing on the South Street, looking toward the North IL building, you can see that the stairwell tower is now covered with white insulation. This day, the sky was a gorgeous blue with soft clouds, and the trees were only moving a little bit in the wind. Huge blackbird was playing in the puddles, but stopped to watch me as I passed. An official Alta Vista cat looked a little suspiciously toward me, like what was I doing in his neighborhood? From the casita wall, I can see that the sliding glass door has been installed on that IL apartment. I can even see framing in the window. This worker, thankfully with a harness on, is putting more of the white roofing material on the balconies of the IL building. Down below, footings are being installed to be able to pour curbing and gutters. Next day when I walked up there, they had poured the curbing and gutters, and it had rained and made everything muddy. On the dry day, I heard a scritching and looked down and saw a worker cleaning off all the old concrete. He was getting the wall ready so the guy with the stinky brown waterproofing could come along and do his job correctly. They are getting it done, but I think it rained after they finished by the look of that trench. Rumbling and clanking made me glance up to see this worker measuring, cutting, and getting ready to install pieces of support underneath the existing balcony. In the shadow of the SkyTrack, these two workers are installing a fire hydrant at the northeast corner of the IL building. Walking back from the casitas, I am struck by even in rough, kinda ugly circumstances, beauty will find a way to thrive. So, to change the subject, I've been having some conflict with our scooter Hawk. He seems to be developing a real attitude. It started a few weeks ago when we went to visit friends. Every month, Christian Motorcycle Association goes out to Montesa Park. This is actually a city park out by the airport. Hawk saw big motorcycles with fancy pipes and decorative saddlebags. Our friend Dean in red teaches people to ride motorcycles, from 5-year-olds to 85-year-olds. This particular lady is a stunt woman in the movies in Cars and Trucks, but she wants to learn to ride motorcycles. Hawk was fascinated watching 4x4s trying to conquer the hill. Even if some of them didn't make it, he thought it looked like great fun. If you make it to the top, you work your way through the split in the ridge, and once you do, you hit the gas and go as fast as you dare down the hill to the bottom. Hawk really liked this part. So the problem is, Hawk wants to be big, he wants lots more chrome, and off-road tires. I can't convince him that it will not work for him. Another beautiful sunset, but I think we're going to have to revisit this discussion with Hawk later.
Sides of the roadway, and there's not much progress on the retaining wall this week. So mostly there's a little more yellow and a little more white, all except on the highest level. Hi, this is Jack Breyer. It's Wednesday, May 5th. 9 a.m., 60 degrees outside and sunny. I'm trying to get the parking picture on the portal, but that guy who runs the portal, I think his name is Breyer, is kind of incompetent. On the east end here, the most interesting thing is Wilbur's shadow going along the near end of the roof there. Coming around the east end and down the south side, we see along this wall that things are mostly the same as last week. Again, a little more yellow, a little more white. Oh, by the way, the hatch is open. Can't they close that door? Anyway, look down at the west end. You can see they're starting to put on the white insulation. That's surely a sign of progress. And Block Monster couldn't be happier. Coming around the west end here, look down on the road in front of the carport. That dummy's standing in the middle of the road. Can't they get rid of that guy? He was there last week too. And now coming around and looking east, we can see that the upper right corner still doesn't have yellow. NASA Ingenuity successfully completed its fourth flight on April 30th, flying 16 feet in the air, 150 yards out, and then 150 yards back. The total flight time was 117 seconds, and it took 60 pictures, including lots of stereo pairs. There doesn't seem to be any video of the flight available yet. What you see is flight number 3. The upcoming 5th flight is a one-way flight, flying out and then landing in a new place. And it represents the start of a transition. The mission so far has been to prove that flight is possible on Mars. Ginny has done that very successfully. Now Ginny has been so successful and Perseverance is ahead of schedule. So Ginny enters a new mission phase with the 5th and 6th flights. There will be 2 goals. 1, to explore how it can be used as an aerial scout for Perseverance. And 2, to extend its flight envelope and practice precision maneuvering. This phase, starting as a life of about 30 Martian days, will end for sure in August during the solar conjunction, which is when Mars is on the exact opposite side of the sun from Earth and communication is very difficult. Ginny is a distraction for Perseverance, so there'll be no more pictures and videos from Ginny. Perseverance plans to spend the next year in the Jezero crater within about a mile of its landing site. Ingenuity will take about 1 flight every 2 or 3 weeks, and Ingenuity will explore areas of interest. It will also test how high it can go, how fast it can go, how quickly it can transition from one flight mode to another, and how much it can tilt. So this is its barnstorming phase. It may crash, but it has already been so successful that no one is worried, except, of course, Wilbur. With that thought, let's look at assisted living. Along the south side here, they are done with the stuccoing. So they're so done that they're removing all of the scaffolding, and they have a lot of cleanup still to do. We also get a peek at the retaining wall. They've partly backfilled and they're tamping down the stuff they packed in. We can see that they've finished the paving of the pull-through area by the lobby, and note on the roof that the hatch here is closed. The lobby roof, which used to be white, but now has collected a lot of brown stuff, I think that's called enchantment. Now, jumping over to the back side. We see that this side is the same old, same old. On the east end, everything seems to be done, and as we come down and look at the west end, we see it's still entirely yellow. We can see on the west end here as we come around that the windows have been installed on the Solaria bump out area. And to finish up, as we come around, we get one long last peek down at the retaining wall. That's it for this week. Have a good week. Hello from Independent Living. You can see they're doing curbing on both sides of the road here, in front of the building and on the left-hand side. Some work also has been done on the retaining walls, waterproofing the back of the wall. But basically, this week is the week of more yellow and more white. As we come along here, you can see two guys there working on the second and third levels. The guy on the left there is working on patching up and touching up all the yellow coating, making sure it's covering everything. And the guy on the right is putting down the white covering on the patios. He's working on the adhesive that goes underneath. That's about the most interesting thing this week. It's Wednesday, April 28th. It's about 9 a.m. It's 50 degrees and a little bit overcast and might rain later on. And now as we come around the east end, you can see they've added insult to injury by pouring concrete over my carrot patch. You think those carrots are going to work their way up through the concrete? Look down low and you'll be able to see more curbing along the south side of the building as we come around. Otherwise, there's not much to comment on this side of the building. The hatch on the roof is still open and Black Monster's still there, straining at the constraints. Look out over C&M there to the north. Do you see the coyote? Neither do I. But there were two of them here yesterday. And now, as usual, as we come around the west end of the building, we get our long last look toward the east. And we notice that in the upper right-hand corner, they still haven't covered that patch with yellow.
There's two very critical pieces of hardware on a drone that allows it to fly autonomously. Today we're going to cover what the difference is between a flight controller and a flight computer in the context of an autonomous drone and why you might want to keep them separate for your particular project. There's two key levels of control that are going on behind the scenes in an autonomous drone. Of course, much more complex systems have many levels with specific functionality, but I want to focus on the bare minimum in order to have a drone do something useful entirely on its own. The inner loop controller is what stabilizes the vehicle either at a specified angle or vehicle body rate. Drones are inherently unstable. They require active stabilization to the motors to keep it in the air at all. Without this, even the most skilled of pilots could not keep them in the air for more than a few seconds. The outer loop controller can be thought of as a simulated pilot that is generating pilot commands. It does this in response to various sensor data used to figure out where the drone is in space to get it from point A to B without crashing. We call the board that handles inner loop control the flight controller. This is the heart of the drone that allows a pilot to talk to it with a requested vehicle state and output stabilized commands to the motors to achieve that state. A flight computer is what is used to conduct all outer loop control and request a vehicle state from the flight controller just like a pilot does. The flight computer is the decision-making brain of a drone that makes this request as it is informed by various onboard sensor data combined with what specific task it should be carrying out. For example, GPS data tells the flight computer where it is in space. If the mission is to travel from point A to B, then the flight computer must generate the required commands to the flight controller to navigate the drone accordingly. Let's take a look at what processes are occurring in the flight controller or inner loop. First, accelerometer and gyro data is pulled from the flight controller's inertial measurement unit. This data must be processed with some sort of filter in order to estimate the drone's orientation, as individual accelerometer or gyro data cannot do this alone. The simplest and least accurate filtering technique is called a complementary filter. The most accurate filter may be a Kalman type filter, though it is very computationally costly. A Madrick filter is a good compromise between the other two. Next, the flight controller needs to know the desired vehicle state, or set point commanded by the pilot or flight computer. This set point is used to compute the error in the drone's current orientation from where it is desired to be. A PID controller is used to generate stabilized signals based on this error. These signals for each vehicle axis of rotation can be applied to the drone's motors according to the dynamic configuration in the control mixer. For example, to stabilize pitch, the forward motors and rear motors must receive opposite stabilized signals. We then write these signals out to the motors, which in turn generates a vehicle response. This response is again measured by the IMU, and we have created a feedback loop. Typically on a flight controller, this process runs at 1,000 or more cycles per second. So now that we can see all of the challenges that must be solved in order to complete this loop, let's see what this looks like in action. The previous flight controller loop diagram can be supplemented with additional filtering, control techniques, or safety measures. With a properly designed and tuned controller, a very fast and accurate response is possible. Next, we will look at the operation of the flight computer. This is a very broad overview of what could be happening on board, though the specifics vary based on the application. Because there is so much going on, it is not necessarily a loop either, but a continuously updated stream of input and output data. The flight computer needs an interrupt handler to process sensor data as it becomes available. A popular system used is ROS, which allows for easy access across multiple sensors, computations, and outputs. An autonomous drone might have a combination of cameras, LiDAR, or GPS on board. This sensor data is used to estimate the drone's position in space from information about its surroundings or movement, which is known as odometry. Once the drone knows where it is, a mission planner can be used to decide where to go next. A typical mission planner might look something like this. It must first decide what the current task is, for example, flying through a window. Next, the mission planner may request that the drone search for the target by either flying forward or turning around. Then once the target is identified, it must converge on it to ensure that it has actually found the target and not something else. Finally, the desired maneuver for that target can be executed. Once this is complete, the mission planner decides what to do next. The mission planner conducts its operations and in the process requests that the drone moves around. A controller is used to generate requested vehicle state set points based on where the mission planner wants the drone to be and where the odometry thinks the drone is. These requests are then sent to the flight controller at a rate of about 50 to 100 times per second. Here we can see that full and complicated process in action in a simple autonomous landing demo. The mission planner's goal here is to land on the target. It first performs a forward search and then once the target is identified by a downward-facing camera, requests that the vehicle begins to descend as the detection algorithm converges on the target. You might rightfully be asking, why not just do everything on the flight computer? My answer to that is you certainly can, and many companies such as DJI do that with their custom boards to save power and weight. But if you are assembling your own system, you may run into some problems. First, the flight computer speed is not guaranteed constant, which is a problem for stabilizing a vehicle which requires constant, high-speed operation to stay in the air. A flight computer CPU may become overloaded if excessive computations are being demanded from computer vision algorithms, which slow down the whole system or even crash it entirely. So generally speaking, it is best to have a dedicated single-task microcontroller for stabilization that guarantees the vehicle will be stabilized regardless of the health of the flight computer. In the event that the flight computer encounters an error, you can always switch back to the pilot transmitter to safely land the vehicle. So to answer our original question, the flight controller is a dedicated board to simply stabilize the vehicle, whereas the flight computer performs all the onboard decision-making and sensing, much like a pilot. Both are very important for safe and reliable autonomous drone operation. This was a very broad overview of some of the things going on inside an autonomous drone and is by no means comprehensive. I hope you've learned something and you now have a better understanding of some of the topics that need to be addressed to create a fully autonomous drone. If you're interested in some more of the nitty-gritty, check out my other video on a fully autonomous drone completing an obstacle course and how we did it.
Here at Assisted Living, we can see that they've applied the gray base coat and over that a pinkish color coat on most of the building. They're still working on some of the lower levels of the building where the drains of the EFIS system are, and down at the east end there's an area they haven't done at all. They're also working on the retaining wall, backfilling some of the areas and packing it down. Here in the lobby area we can see that not only have they poured the curbing, but they're now in the process of pouring the sidewalks along the front of the building. And skipping ahead a little to the back side, we can see that they're working on stuccoing my wall. They've put on the yellow coat and have the insulation almost all installed. And coming along the north side of the assisted living building, we can see that just like last week, it looks pretty well finished on the east end and not much progress at all on the west end. And the same is true as we round the west end. The most interesting thing to look at here, just like last week, is the retaining wall, where they're backfilling and tamping things down. They've installed special drainage mats to prevent water from building up around the back of the wall. See you next week.